Hello, welcome to Calculus in the PM. I'm your host. This is part 2 of, get this going here, part 2 of my velocity and other rates lesson with you. It's only one example that we're moving, a moving particle here. Now, here's a function, s of t. We're using s to be a position, sort of like a distance function, right? And the particle moves along the line, so its position at any time where t is larger than 0 or equal to 0 is given by this quadratic function. Now, s is meters, measured in meters, t is measured in seconds, okay? By the way, when you do word problems for me, you need to try to get units for things, like if I ask you, how long will it be, or something like that, 3 days, or 2 hours, or whatever, that kind of thing. Anywho, A, find the displacement during the first 5 seconds. Okay, we talked about displacement before, and it's different than position, right? What do you have to know to find the displacement? What is displacement in regular words, non-physics words? Distance between start and end. So the first 5 seconds, start at 0, where were you? Started, and then go to 5 seconds, the position there you go. Now, how do you find the position at 0? How do you find the position at 5? Yeah, there's no calculus involved, right? You put 0 in there, you put 5 in there. You guys have calculators too, right? If you want to do it that way, but I think you could even do this in your head. Now 0, I'm going to look at this here. 0 minus 0 plus 2, so it starts at 2, right? And 5, s of 5, when I plug 5 in here, 25, I'm thinking 3 times 5 is minus 15 plus 2. I can do this in my head, right? 10 plus 2 is 12. Everybody with that? So, the displacement during the first 5 seconds, do you guys remember something about finding how long you've gone? You always go final minus initial on your odometer on your car, right? You know, the rolling count of stuff. Final minus initial, right? So always in physics and in math now. So I'm going to just write that out in words, okay? Displacement. Now, direction is important. That's why we have to do it in this order. Displacement, really, it's the change in s, change in position, right? And it's equal to final minus initial. Here, I'll say words first. Positions. Now, in words, that's what we're doing, but in this particular case, and I'm going to write it in symbols. We've already established that it's 12 and 10, so it's, or 12 and 2, it's 10. But let's get this so it's more helpful for you if you have a different problem. So, the displacement here, the change. I'll say change in s, right, is the final, so I'm going to call it s of 5 minus s of 0. The position at 5, the position at 0. We already established. This is bugging me with the dotted line, so I'm going to just flip the page. Oh, I thought that would undo it. There. Okay. I'm going to work sideways. I don't typically do this. But 12 minus 2 equals 10. Wait a second. That's almost the right answer. Meters. Meters. Good. Now, if you want to put 12 meters minus 2 meters, that's even better, but I'll let you do it. Wait till the end, if you wish. And that's a positive 10. That means you went whatever we're calling the positive direction, north, south, east, west, up or down, etc. It's how it's defined. Absolutely. If I define where I'm standing right now as 0, and I go ahead 1, 2 meters, and negative movement, I'm 3 meters back from where I started, so that's negative 3. And in the context of this, West being the way I was walking, west was positive, east is negative. So it means I'm negative 3 in that case would be negative 3 would mean 3 meters to the west from your starting position. Okay? It's all relative to a fixed reference point. And we could get into a debate about there's no fixed reference points in this universe. But we have an intuitive understanding, right? You know what I'm talking about. Let's see. Okay, because as soon as I say that, that opens up another can of worms. But find the average velocity during the first 5 seconds. Still not doing calculus. The average velocity, do you guys know in words what it is? Yeah?
It's the slope.
It is, it's essentially the slope. The change, in this case, we're talking about the change in position or displacement divided by the change in time, right? So yes, average velocity. So is like the slope. It's a slope calculation. We won't do any calculus, that means. It's like a slope. I'll put kind of. It's the slope between 2 points. So in this case, because it's actually a curve, so it's not really, it's the slope of a secant line or between 2 points to be better. But we're going to just say average velocity is equal to, in this case, the change in position over the change in time. Guess what? We have the change in position, 10 meters, positive direction, 5 minus 0 seconds. 2 meters per second. Okay. That's average, not instantaneous. So then what? C, instantaneous velocity when the time equals 4. How do you find an instantaneous? We need a what? The derivative to find the velocity function, right? So, why? Because the derivative of a position function will give you velocity. The second derivative of a position function gives you acceleration. Okay, so C. Where was I? Oh, right. We need the velocity as a function of time, which is equal to ds by dt. Now you could skip this, but I'm just saying what we're doing, the derivative of the s function with respect to time. I could have put s prime of t as well. I got to look at that though. Okay, 2t minus 3. Simple enough function. And it's at precisely at 4 seconds. Yeah. So v of 4 is equal to 2 times 4 is 8 minus 3 is 5. What's the velocity unit in this case? That's, you guys are familiar enough, I think, with speeds and velocities that you know it's meters per second. But if you're stumped, take a look at this. Okay, I'm describing the change in speed or change in position, so meters per time, seconds. Okay, meters per second. Now, see, d is the acceleration at 4. Let's take a look here. Yes, it is. It's at 4. Acceleration of that? Well, that's the second derivative of that initial position function. Or in another way, you could say it's the derivative of the velocity function. So we've got the derivative of the velocity function. It's a cinch. 2t minus 3, the derivative is just a constant, 2. You might be wondering, though, if you're not taking physics, you might not understand units as much. I'm going to just put this as an aside here. A of t is equal to d2s by dt squared, d squared s. Because that just kind of helps me with my units sometimes. These ones, you probably know units, like I say, but it's later on when you get complicated problems, you might be wondering, what the heck are my units? And you look at this, You say, well, the S, there's no square on it, so it's meters, right? But there's a t, dt squared, meters per second squared. Okay? That's a standard unit of acceleration. Then you'd say, what does that mean? What does that mean, meters per second squared? 2 meters per second squared is the acceleration. I think of it actually, it's better to think of it as, because sometimes you have to describe what this means. It means that every second, if I say it like this is the same thing as 2 meters per second squared, right? This acceleration means that every second you're increasing by 2 meters per second in velocity. Does that make sense? That's really what the acceleration means. Okay. E and, is there enough? Yep. When does the particle change in direction? How do you find, what do you know about something that changes direction? What has to happen in between? This. Okay, but this has constant, the acceleration never changes, it's always 2. My hand, when I throw an eraser up in the air, always negative 9.8. Now I say negative because I'm assuming down is the negative direction. When did this change direction? What was its speed, or velocity? 0. You got to find, first of all, where the velocity changes to, you got to find where it hits 0. But not only that, what if my eraser goes up 0? Did I change directions though? No. And it has to change sign, the velocity, right? Like, has to change directions from positive to negative velocity, right? Now, I think you guys know enough about quadratics to know that where you hit, the initial function is a quadratic, right? And you know that it's going to be like this. When you find a 0, it is going to change directions, right? Some complicated functions you wouldn't know. So we won't have to do any extra tests. But, you know what, I can squeeze this in here, I think. Oh, I'm just going to get some more space here. B, C, D, E. I'll change colors here. So, it asks, when does the particle change direction? Well, first of all, we have to find when the V equals 0, because that's the only time it could, right? Change direction when V equals 0. So we got to look at our velocity function, which is 2t minus 3 right there. Okay. So Nisha, if she looks at this, 2t minus 3, we got to set that equal to 0, right? So 0 is equal to 2t minus 3. I hope you could solve that in your head. You add the 3, divide by 2, 3 halves. 1.5, but t is equal to 3 halves of a second. I'm fine. In Mr. Malik's physics class, you'd put 1.5, right? You can keep fractions here. That's fine. 3.5 seconds. And that answers when it changes direction. Okay, it does, yep. If you check the velocity between 0 and 1.5, 3 halves, it'll be one direction, and it'll change directions, like one will be positive, one will be negative, right? As far as the velocities. Negative, then 0, and then positive. Okay, E, oh no, E, that was F. Where is the particle when S is a minimum? Position is a minimum. Now, what does that mean?
Your speed is 0, or is it velocity?
Yeah, we know enough about this function that we don't have to check too much. When your speed or velocity is 0. Yeah, we'll use the word velocity here, but like I said, we know this is a quadratic. And if I sketch this, it would be something like this. You don't know the exact spot of this until we found out it's 3 halves, right? This is the position. The velocity is 0 there, so that should be the minimum, right? Does that make sense, just from what we know about quadratics? Okay. If you had a really crazy function involving cosines and e's and stuff, you'd need to do some extra tests. But I'm assuming we remember a little bit about these functions. So e, f. We know from e it's at 3.5 seconds, the minimum. So the minimum. Is that how they call it? Yeah. Min s value, position point, is s of 3/2, which is equal to, well, you can use a calculator if you wish, but 3/2 squared is 9/4. Good gravy, why am I doing this? But 9/4 minus, was it 3 times 3/2? Yeah, minus, so 9/2 plus 2? Okay. What's 9/4 minus 9/2?
Negative 9, or is it?
Negative 9.
Yeah, negative 9 quarters.
Negative 9/4.
'Cause it
Yep.
would be, yeah.
Negative 9/4, okay. Yeah, it is, I'm getting myself mixed up, it is. 'Cause, yeah.
So negative 1/4.
And then, yeah, plus 8/4, 2 is 8 out of 4, right? So like you said, negative 1/4. Negative 1/4, or negative 0.25, what is this measured in?
Meter.
Meters. Yeah. Let me try to squeeze that in. Little m there, that's kind of messy. Running out of space. Negative 1/4 meter. Negative 0.25 of a meter. So that means, I think Jaden had asked a related question earlier about, can you have negative position, negative displacement? If you only did displacement from 0 times 0 to time 1.5 or 3/2, what was it at 0? It was 2. And then if you started at 2 meters, 1.5 seconds later, you would have went 2.25 meters, right? In the negative direction, that displacement. And then from there on, it's all positive displacement from 1.5 on. Okay. Now, I ran through this kind of quick. I'm just going to release you to do some questions here, but I'm going to first stop this.